All right, let's look at a different way of applying the dot product to calculate something useful about these two vectors. So we know that the dot product, or the scalar product, has a form that includes the angle in between them. So if we know what the vectors are, we can in fact calculate the angle in between them. Usually this will give us the acute angle. So the dot product algebraically is 5 times -2 plus 4 times 3. And then the size of A is a bit of Pythagoras, 5 squared plus 4 squared. And the size of B is a similar bit of Pythagoras, 2 squared plus 3 squared, times by the cosine of theta. So this is -10 plus 12 is 2. This is root 41. This is root 13 cosine theta. So rearrange this. The inverse cosine of 2 over root 41 root 13 is theta, and your calculator will tell you what that is. We get roughly 85.0 degrees. Okay, and then there's nothing about this that depends on this being a 2D vector. We could similarly do this with a 3D vector. So if we compare these two vectors, if we assume they start from the same place, what angle is in between them? Well, the algebraic form is 3 times 2 take 1 times 3 take 4 times 1. So I've automatically used the negatives here to deal with that. And then a bit of Pythagoras, 9, 1, and 16 from those. 4, 9, and 1 from those. By cos theta, so this is 6 take away 3 take away 4 is -1. This is 26. This is 14. Rearrange this. Take the inverse cosine. And that will give us -93 degrees. Okay. So the acute angle therefore will be 87 degrees. Right, one more example, because it's quite an important special case. I'm happy to do this in 3D, but you could easily do it in 2D. If we do 1, 2, -1 as a vector, and we have -4, 3, 2 as a vector. Again, applying this system, we get -4 plus 6 take 2 equals square root of 1, 4, 1 by 16, 9, 4 cosine theta. Now this left-hand side, -4 plus 6 take 2, is 0. When I divide that through, I get 0 equals cosine theta. And as you should know, the inverse cosine of nothing is a right angle, which, as I've got it at the moment, is in degrees. So, this is a very, very important result. If things are perpendicular, you're going to get a dot product of 0. Now, we're going to use that fact a lot, either to make sure things are perpendicular by selecting values that get us 0, or by confirming that things are perpendicular and therefore we've got short paths and things. So the dot product being 0 for a perpendicular is probably the most common algebraic check you're going to be doing calculating the angle is useful, but it turns out perpendicularity is quite an important geometric property. So being able to calculate it algebraically is very helpful. So I hope that makes some kind of sense.